Good morning to everyone. Let's go for today's class. Before enters today's class, let's recap what we studied in the previous class. The previous classes we studied the combination circuit, how to write the program in the behavior modeling with using if statement and the case statement. I hope no issues in that. I hope you might have understood. Additionally, we added something extra. It's called as concatenation operator. This one we introduced newly in the previous classes. Now what we'll do, let us write the program for sequential circuit. Because earlier we wrote the program in combinational circuit. As you know, what is the basic difference between combinational circuit and the sequential circuit? The combination circuit, it doesn't have memory, but the sequential circuit, it has memory. The one more thing is the combination circuit, the present output is purely depend on the present input. If any input changes immediately, it will reflect in the output. The same, if we go for sequential circuit, the present output is depends on the present input as well as the previous output. That is what we can say sequential circuit. So only we are saying it has memory. Now, what are the different types of latch or the flip-flops are there? So already, as you know, the first one is nothing but SR flip-flop or latch, we can say. SR flip-flop or latch, then D flip-flop. Then third one is JK flip-flop. The fourth one is T flip-flop. So this is the four we study today. Along with that, counters also how to write the program. So before enter into this flip-flop or the latch, we must to know what is the very basic difference between latch and the flip-flop. Is there any idea? The very basic difference between latch and flip-flop.
So in latch, we don't apply clock pulses.
You people are like that only you studied, I hope, in the digital design, right? So like you won't have the latch, you studied like this one, like in latch, we won't use the clock, but in the flip-flop, we'll use that clock. But as we know, the clock is nothing but a one control variable actually. Otherwise, I can say clock or enable, we can say. But that is not the true answer actually. But if they ask the question, you should be able to say what is the difference in the sense. The latch in the sense, it is a level sensitive actually. It's a level sensitive, but the flip-flop is level triggered. Level trigger. So the very basic difference between latch and flip-flop is it's a level sensitive. The latch is a level sensitive. The flip-flop is a level triggered. It is nothing but it's a edge triggered. The flip-flop always should be based on edges only. But the latches will not work. It will work on the level. That is what I can say. What is the meaning of that level and edge you may have? So for the simple, let me show. Let me take a one simple. That is the control variable is nothing but the clock. So let me take a clock. See, this is the clock. But as you know, you studied the clock as like this. I hope you remember. I hope everyone has studied the clock as like this only. I think it's correct. Everyone you studied like this only clock. But that is not the true clock sir. Actually. But it is not a true clock. If you want to generate a one clock pulse, what are the parameters are required? You have to see here. What are the parameters are required to generate a one clock pulse? One clock pulse means, which one I can say one clock pulse means from here to here. One on and another one more off. Period will be considered as a one clock cycle. Now, if you want to generate like this, what are the parameters are required? The parameters are, the first parameter will be what? I can say T or something I can say clock time period. time period is required. Next, on time is required, off time is required. Then you may need the logical, like logical low, high voltage, low voltage, even that also is required. Or I can say on time, off time, I can say, or simple, I can say instead of that, I will call as pulse width. I will call as pulse width. Time period, pulse width. Then very important, one more thing is there. You rise time, then fall time. These are the parameters are required to generate a one clock pulse. As you know, the pulse width is nothing but this is the one pulse actually. What is the width of this pulse, which includes the on period and the off period. Then time period is nothing but for how long you are going to generate. Then rise time, fall time. As you know, rise time, fall time here in this clock signal, it is zero actually. Rise time, fall time. What is the meaning of rise time and fall time? For that, let me show how it will be normal. This is not the original clock. Now, let me draw the clock, how it will be. See, this is the normal, actually, original clock. This is the clock, actually. So, here only I can say, see, from here to here, then from here to here. So this period only I will consider as rise time. That is, I will call as TR. Then this I will consider as falling time. That is nothing but TF. How we can calculate the rise time and the fall time? The time taking between the 10% to the 90%. 10% to the 90%. See, 10% to 90%, the time period. The logic from the transition from 0 to 1. That one is nothing but rise time actually. So this is what we called as rise time calculation. The fall time is same as like the time taking from the transition between 1 to 0, how much? The 90% to 10%. That is the falling time. So you compare these two, what is it here? It is a level. Exactly, see, straight line is there here, right? Meaning is what? The rise time also is 0, fall time also is 0. Why? Because you can see if I take the period as like this, see, if I take a period as this 0 seconds, that is nanosecond, I will consider this is the time is nothing but 5. Then I will say this is nothing but, because here only we are having a level, see, between this level only it is logical high value, correct? This only the logical high value here. Up to here, from this portion to this portion, this portion to this portion, I cannot predict whether it is 0 or 1. Correct? It is transition from 0 to 1 actually. So that is why I can say this is 5. You consider this is 10 in the sense. So between you may have, this will be like something called as 7. This may something called as 8. So this will be 2. This also will be 2. Then this will be how much then? 3. I think now we make it correctly. 5 plus 2, 7. Sorry, it is maybe 1, right? Then because here is 10. 7, 8, 10. So it will be get splitted like this. Now I will say from this, what is the difference between latch and flip-flop? Now I will consider my one clockwise cycle is this. I will consider this is my clock cycle. So what I will write as this is nothing but T. This is T actually. Now, as I said, what is the latch is? Level sensitive. You might have got it. It's a level sensitive. Level sensitive in the sense your flip-flop or your latch will work only during the level sensitive, means when level is high or low. So let me show how it will be. See here only. See here. This is the level. See, this is the level actually. So then this is the level. So your latch will work during this time only. In the sense, it is a storage element. As you know, latch is a storage element. It's a 1-bit storage element. Latch is a 1-bit storage element. So now, from here to here, between this is what the 1 will be stored. See, same even here also. That is why I can call, if this is the Clock signal means when your information will be stored, the data will be stored during this time only. That is why I can call this level sensitive. Level, this is the level, this is the level. I hope you might have got it now. Now, as I said, flip-flop. Flip-flop means it will say levels triggered actually, in the sense the flip-flop will start to work in the edge, starting edge of the clock itself. Trigger in the sense we are having two different types of triggers are there. The one is the positive edge trigger, types of trigger. You may know that this already. Types of trigger. What are those? One is positive edge or positive trigger. Positive trigger. The second one is negative edge or negative trigger. Or I may call this logical high. This may call this logic high, right? Logic high level. And this may call as logic low level. This one. Logic low, this one. So now your flip-flop work based on the edge of the clock. So edge in the sense, how can I say in the sense? You see, this is the edge, this is starting edge, correct? This is starting edge. So your flip-flop will start to work here itself. That is the difference you see here. But one more thing, whenever the levels are changing in the sense your latch. So if the input is changes, especially very important thing here, if the input is changes during the level, the output also will get a reflect in the latch. But in the flip-flop, even though if the input is changes, the output will not change. So I can say your data will be start to store the starting of the edge between this edge to this edge here, this portion here. Even if the input is changes continuously also, the output will not change. That is the very, very important here. So when you go for a diagram, I will show clearly how it is in the D flip-flop next time. So this is something but a latch and flip-flop. So simple, latch will work during this time only. Next day, during this time, if any input changes here, in the sense here. So let me show where here. During this time, any input changes, the output also will get changes. If you are working your latch in the positive, if you are working your latch in the negative, then if any input changes during this, then output also will get reflect. That is the reason we won't use the latches, we'll use the flip-flops. Very important. That is what, because of even though input changes, output should not change. That is why. So it is maintained. So now what we'll do, let us start to write the program for write the Verilog code for SR latch. Okay. So to write the SR latch, later I will write SR flip-flop also. Both I will show. First, what you need to know the truth table. Why? Because we are writing the program in the behavior model. So if you want to write the behavior model, you must to know the truth table of SR latch. So what is the truth table of SR latch here? So let me take the truth table of SR latch now. Truth table. Before there one more diagram also I need to draw. So let me draw the diagram here. This side, SR latch. This is S, this is R. Okay, see this is a latch. So now here one signal I'm giving. As you know, I'm giving as clock only even. See, it is not like a given clock means you may think for latch is not a clock is not there. You said like this only. But I'm using the control signal as here clock only. But you might have studied as enable. I think you remember that. So as per for your better purpose, what I will do, I'll use as like that only. Enable. Both are fine. Anything you can use. Let me use. I'll come for your convenience only. I'll use as this is enable signal. Then we'll have the two outputs. One is Q, then another one is Q bar. Okay, so now let me write the truth table. So for truth table, first is enable signal. Enable. Next signal is what? Next signal is yes. Next is R. Next is Q. Next is Q bar. Okay. So now you see, when you can write your program as like you can start to work anytime. In the sense, okay, yes. So now you can write the program either active low enable or active high enable. What is the meaning of that? Active high enable means your latch will be work when enable is high. Active low enable means latch will be work during the low enable is equal to 0. That is negative, I can say. Now what I will do, I will write for enable high. So when enable is high, then our SR latch will work. So first combination what I'll give as 0, 0. Both are 0, 0. What is the truth table here? This will be no change. Yes, this is no change. What about here? Q bar also, it will be no change. It will be like this only, right? Next, enable is high. 0, 1 means set. S is set, R is reset. So we are going to reset it. In the sense, what I'll get now? If you are resetting, then Q will be 0, then Q bar is 1. Next, enable is high. 1, S is 1, R is 0. That is meaning is we are going to set. So Q will be 1, Q bar is 0. Then enable is 1, S is 1, R also is 1. Then what is Q? Q is unknown. Q is unknown. That is Q bar. Both are unknown. Next, see, we seen when enable is 1 means your latch is working. Now we need to see when enable is 0, what will happen. So I can say when enable is equal 0, S can be anything. That is X. Your R also can be anything. So what will happen now? Any idea now? Enable is 0. When the enable is 0, if the input is means both are 0, so I can say it can be 0. I will say like this. Or output also unknown, I say. When enable is equal to 0. So two things I will do. One is something but I can say when enable is equal to 0, it has to maintain the previous value. That is the one I can write. Else, if the enable is equal to 0, the latch will not work. In the sense, I can make it as 0 or I can make it as X also. It is left to us only. So what I will do, I will make it as like a 0. Better I will make. Enable is 0. Q is nothing. Q bar also will be like what? Both will be 0. Instead of that, I'll take it as X only. Even this also is X. I hope you might have understood this. Now let us write the program in Verilog. How to write now? Let us start. First, module. First start from the module. Module followed by SR latch. SR latch. Then what are the inputs? See from the figure. What are the inputs and the outputs now? S comma R comma. Next is enable signal. Next Q. Next Q bar. Q bar. Next will be semicolon. Next you have to specify input. Input S R then enable. Next output. Outputs are Q bar. Enable. Okay. Next register. Register Q comma Q bar. Yes. Next we have to go as always at what are the input signal now? Input signals are S comma R comma enable. These three. Or what I can do in the sense even only enable also I can write because based on the enable only the S R if it is changes it will work because your latch will work based on the enable signal only. Okay. Next begin. Now let us use either if statement or a case statement. Now let me go for the if statement only. So let me use if statement. If yes, S is equal to 0 and R equal to, very important, one more thing I left out here. What? We are having enable signal, right? So if enable close, see, I'm not used here. Enable is equal to 1. Only en I used. This is the one more, the new concept I'm adding here. In Verilog, if you write en only, by default, it will consider as enable is equal to 1. That is, enable is I. If you want to make enable is equal to 0, then what you have to do in the sense, you have to make it like this. Exclamatory mark you have to put. That is this negation mark. Exclamatory mark you have to use. This is enable, it means low actually value. So you can write like this also, or if you are getting any confusion, even you can write as like this also. Both are same. Enable is equal to 1, then enable R equal to 0. Yes. Now, if the enable equal to 1, then S equal to 0 and R equal to 0, then what is Q? Two output statement is there. You see Q and Q bar is there, correct? So what you can do now? Both are registered given. So begin and you have to use. So what I will do instead of that, each and every time you have to use begin and okay. Let me use a better same like this only. Begin Q equal to what? No change. What is the meaning of that? No change means it is nothing but a previous value. Means
0.
it's not is 0. How it will be 0? Enable is equal to 1, S equal to 0, R equal to 0. What I'm going to do? Q is equal to Q because I doesn't know what is Q. You might have understood now. We doesn't know what is Q because initial value is given S equal to 0, R equal to 0 because I will show in the waveform actually. Then only you can come to know Q is Q. That is the meaning of no change. No change means in your truth table, in your logic decision, you might have studied Q will be there. Here in this place, it will be Q bar only in this place. So Q is Q.
Memory.
Is any confusion in this?
No, sir.
Is it clear, right? Q is Q. Actually, Q is Q. Then what about Q bar? The Q bar is also Q bar only. But you may think, what is the value of Q? So that we will do in the simulation. I will show what is the Q will be. Or you can use here one more input signal here called as like additional one more signal also you can reset set as there. No, you can make it here S equal 0, R equal 0. Instead of that, so I'll show in that program better in the diagram. I'll show. Okay, next begin end I should use. Why I'm using begin and end? I hope you know that because of the reason is we are having two statements here. You see. If I'm having only one statement, then begin end is not required. But two statement, more than one statement, you need to use begin end. That is, it is a resemble of your C program. You might have used open brace, close brace, same. Next, second, what I will do? Else if yes, S is equal to 0 and R equal to 1. Begin, yes, begin. What will be Q now? Q equal to 0, 1 means that is S0 actually. It is 0. Then Q bar is 1. Next end. Next again. Else if S is equal to 1 and R equal to 0. Then begin Q is equal to 1, Q bar is equal to 0. Then end. Now you see only the last condition also we have to write. Why? Because we must to show when enable it to 0 what that we have to show. So that is what you will do. Else if again. Else if S is equal to 1 and R equal to 1, then what is the Q? The Q is what I can say now. Q is unknown, I said. Q is unknown means we have to say X. See, very, very important. Q bar also X. Because when in the SR flip latch, both are equal to 1 in the sense it is an unknown value or it's an undefined value. So it is X. You should not use capital, that is uppercase. You must use the lower case you have to use because it is case sensitive. Next, end. Still the program is not yet over. What you have to do? So let me do that else condition. We have to go for else condition. For what purpose this else condition now? This is for if enable 1. See, because if enable is 1, if the condition is true, then from here to here it will execute. But if the enable is 0, what will happen? It will go to else condition. Then here again we have to write begin. Begin Q equal to we return in the truth table as X we return. I'll keep it as 0 also, no problem. We should not get confusion. 0, then Q bar also 0. It should not be 1. Q bar also should be 0. Both should be 0. Then enter. Okay. Next, what I should do for if statement is over. Next, this begin is the no. We must to close the end. This end is for that begin. Next is end module. See, this is what the program. See, let me show how the hierarchy is there. So this is the one hierarchy. Yes, see, yes, this is what. If you want to go for this one, this if is here. Else is for this here. See? If else, then this end is for this begin. I hope you might have cleared this. This is a program in Latch how we can write using if statement. Instead of this, if you are using if statement, like this will be there. Instead of that, what I can do in the sign, I can minimize this program using the case statement. It will be very, very easy. So let me use with the case statement now. Before that, is it clear? Is there any problem? Did you understood? Let me write the same program using case statement because it will be very simple now. See, module, the same thing will okay. Module SR latch. Now what I will do, I will call as SR only. This is SR is 1, then enable, then Q. I'm not going to use Q bar here. Let me show only with the Q because Q bar asks, you know that Q bar is complement of Q only anyway. So let me use only Q here. Now input, the input SR. So it is a SR is 2-bit, right? So what I will do now, 1:0 I will use. So it is SR. Next input is enable signal. It's a scalar value. I'm using vector value for SR because 0, 0, 0, 1 is there, no? 1, 0, 1, 1 because of that purpose. Next output. Output is Q. Next register is Q. Next is always at SR comma enable. Now let me write begin if enable. Now you might have know that if enable is once, enable is 1. That is the meaning of that. If enable, it will enter into case statement. Case, what is that? SR. Because it's a vector type. So case SR. Now what I will do? 2-B00. What is the meaning of that here? This is yes. Which one? This one is yes. This one is R. So 0, 0. Then what is Q? Q is equal to Q. Then 2-B01. 0, 1. What is Q? Q is equal to 0. Next, 2 dash B 1, 0. 1, 0. Q is equal to 1. Next, what condition? Next is final condition. So what I will do, I will write as final condition, default condition. Default, where Q will be what? Q is X for 1, 1 condition. Next, I will write as end case. Now you see, this case statement will work only when enable is equal to 1. Now what you need to do, you have to show if enable is equal to 0, what will happen? Means enable else, that is else condition, then Q is equal to 0. Then you have to finish with end. This end is for this begin. Then you have to close with end the module. So this is the program for SR latch using case statement. I hope it's a very simple. Now you may think, if I want to add a Q bar in this program, how can I add? Because sometimes we may think, okay, I want to check for Q bar also.